Hello everyone, I'm Anija Jingan. Welcome back to Science Data Science YouTube channel. Today I am going to discuss about the different types of the graphs from the data visualization. Either you are a data scientist, student or data analyst, this video is going to be perfect for everyone. I am going to explore which type of the graph best suits to your data and how you can choose it. I will give you a lot of examples and the use cases as well, and also teach you how you can implement it using Python. So stay with me till the end of the video because you are going to learn which type of the graph is best suits to your data. And we all know if your graph is perfect and it is showing the correct data insights according to your given data set, then your visualization is 10 times more understandable to the stakeholder, right? Well, why it is so important to choose a right graph? Because if you are choosing the wrong graph for your data insights, it's going to mislead the stakeholder or it may confuse them, which we always want to avoid, right? So that's why this is very important and you are going to learn the most important thing or most important part of your AI journey today. So let's start. So these are the different types of the different type of graphs in data visualization, which I'm going to discuss today. This is bar charts, histogram, line chart, scatter plot, pie chart, and so on. I'm going to discuss each and every graph one by one, and I will also show you how you can implement it using Python. So stay with me. Look at your screen. You can see here, this is called bar graph. This is the very popular graph. Mostly we use it in many cases. But first of all, I will tell you the definition and when you should use it and what are its pros and cons as well. Okay. So if you look at this graph on the x-axis, you can see these are the different categories. And on the y-axis, you can see the values. So the bar graph we use for categorical data. If you have a different category exist in your data set, then you can draw this graph to show the frequency of each category or the value belongs to each category. For example, if you have the data set about the your marketing and you have the different products, like let's say product A, product B, product C, product D, and you want to show the frequency of each product to your stakeholder and how much it is sold, the total quantity of the product, then you can use this kind of the graph. So this suits best to your this kind of the data sets. So basically this graph is used to display and compare categorical data using rectangular bars. The blue color, this is called bars, and this is your different categories and this is a frequency. You can also label it with the values. Okay. And when to use a bar chart? When you need to compare discrete categories. Again, if you have some ranges, discrete means maybe the data is in the groups or the categories. And when you want to show, as I have given you the very good example, how many products are sold, product A, how many, what is the frequency to sell it. So you can draw this graph. If you want to show the count, then or percentage of the different groups, right? And when data categories are non-continuous, then you can also use it like the product types, customer segments, and survey responses as well. And when the number of the categories is limited and easily distinguishable. Okay, but don't try to use it if there is a lot of variance in your discrete data. Okay, then in that case you need to create a lot of bar charts which is not will not show the very clear vision or the data insights to your stakeholder. So you can choose what I have written here for this kind of the data set. So what is the biggest advantage of this one? This is easy to interpret because you can see if you have the category A, so what is the frequency of category? You can take it the value or number of times. So this is the 10, and if you want to look at the B category, it is showing the frequency of the B category happening in your data set is 20, and so on. So it is very easy to interpret, and it is very easy to explain to the non-technical stakeholder as well. This is very, very popular bar graph we use. In the next slide, I will show you the use cases as well. So you can see on the right side, this is not suitable for your continuous data because this is only for categorical or discrete type of the data, like if it is some kind of the ranges. And it can be misleading if data is not scaled. What does it mean? So this means, for example, if you want to show the different age groups, right? You have the data of different age groups. You are dividing the age group like from like newborn to up to 10-year old, then you are dividing it to 11-year to 20-year and so on. If there is a lot of variance and there is a like some values which is very low, which is very high, and your data is not scaled, in that case this type of the graph can mislead you. So firstly, scale your data and then visualize your data using this graph if there is a lot of variance in your values. Okay. So cluttered with the too many categories, if you have, as I have told you, if you have a, let's say 10, 20 categories, okay, then does not, it is not going to show any relationship because we are talking about on the variables here, the one variable only on the x-axis. It is, we never use it to show any kind of relationship. We only use a bar graph to show the frequency, number one, maybe values, number two, maybe like the count. These three things, if you want to show to your stakeholder, then you can go with this type of graph, right? I hope it makes sense to you. And if you have ever used a bar graph, just write down in the comment for what purpose you have used this graph. Okay, much appreciated your response. Okay, now we will move ahead the use cases of this bar graph. So you can use it for the sales comparison of different product categories, as we have already taken this example. Customer distribution based on the demographics, like a customer's which product customer is buy most of the time. You can show here the on the x-axis different type of the grouping by the customer, and then you can show the frequency of the products they are buying, right? Survey responses, website traffic sources categorized by device typing. Even if you look for the YouTube channel, you see how many like the people are watching your video on using the desktop, mobile phone, tablet and so on, right? At this time this graph is very, very useful, and you can also see on your website, if you are looking at the demographics of your website, you can see like the different categories again, from which your website they are like visiting using desktop, computer, mobile, tablet and so on. So these were the most important and the top most common use cases about this graph. Now we will move ahead with the next graph. So on the screen you can see this is a histogram. This is a again very popular graph. I have also used these two graphs, histogram and bar graph, many times. I have worked a lot on the COVID-19 cases. At that time, I used these graphs very oftenly. Plus, I have also used the line chart as well. I will show you in the upcoming slides. Okay. So the histogram again is the graphical representation of the distribution of numerical data. It is just kind of your bar graph, but it is used for numerical data. But we don't use the your bar graph for continuous numerical data. If you have the numerical data with the discrete range like some groups, then only you can use it. Okay. And then it is when you should use it when you want to visualize the distribution of continuous data, right? Like if you want to show the heights, test scores and your prices, when you need to identify the shape of the data. So what does it mean? So I will show you here. Let me open my annotate. So we will use this one. So look at this. So what does it mean when you need to identify the shape of the data? If you look at the this graph, right? So it is going like this way, right? So this is seems to be normal distribution, but with some of the this one, this is, we cannot say it's skewness, but it's a little bit outlier, right? So this is going to show you the distribution of the data as well. If your data, its tail is going like this, very long, and your these data points are going till here, so this is called skewness. So this will show you the very clear skewness. At that time, this is very the good and best suited to your data set. Okay. And when you want to detect the outliers, I have already told you this is showing outlier because this data point is very far away from your this mean, right? So this is we call mean. This distribution seems to be all like a normal. It is not showing any skewness. And when analyzing how data is spread across the different ranges, right? You can see here on the x-axis, this is the different ranges. If you go with this one, this is the negative range and this is a positive, right? So it is all, it will also show you the skewness of the data set as well. So this is the biggest advantage. This is very easy to understand. If it is showing the distribution of the data on the different ranges, as you can see, right? The values negative to positive, and this is showing the distribution, the frequency of the data, right? If your value lies between 0 to 1, then what will be the frequency of the data? Above 80. Okay, this is the way how you will interpret it. And if your value is between 0 to -1, then you can see 0 is here and -1 is still here, right? So your frequency of the data is between 40 to 45, or you can say 43. Okay, this is the way how you can interpret the histogram. So the biggest like the disadvantage is it depend on the bin size. Okay, so let's say if you have a very big, like the values, you have a lot of ranges, then it will plot the small bin, then it is loss of its granularity, like a micro level values. It's very hard to like understand. If let's say if I have a values from 0 to here 50, and again this way as well, so it's very hard to detect the frequency, the like the low level of the values. If I want to know what will be the like the frequency level between 0 to 0.2, something like this. Okay, so it's very hard. So this is the disadvantage of this one. This is not for categorical data, this is only for your continuous data. Okay, so now you have seen the two graphs. Main number one, bar graph. So bar graph is for your discrete kind of a discrete type data, categorical data, where you want to display the bars for the different categorical ranges, and you want to show the frequency of each category. And histogram is for your continuous data, and it is very useful when you want to show the distribution of the data. It helps you to know the skewness of the data as well, because we are mainly focusing on the distribution, how the data is spread within the different ranges. Okay, and now again write in the comment for what purpose you have used the histogram. If you have drawn the wrong graph, then you can go back and correct your graph now according to the data type and according to the your requirement. And now we will move ahead with these use cases. So you can use it for exam score distribution because there are different score ranges, right? If you are an instructor, right, you want to test the like the exams, you divide the scores between, let's say, scores between 50 to 100, to 150, or 150 to 200. So this is the range, right? This is the continuous number. And age distribution of the population, right? You want to see the ranges of the age, right? Then you can declare product price distribution, website traffic. So these are the top most common use cases of your histogram. Okay, so if you are working in any of these out of these cases, then this graph is going to be best for your features. Okay, and now we will move ahead with the line chart. This chart also I have used many times in COVID-19 cases. Why? Because I wanted to display the different trends of the COVID cases based on the time, right? In which day, how many cases are occurring at in every minute, every hour, on which date, month, year, right? So this was the very powerful graph when you want to show your data over the time series. So if you have the data set based on the time series, then you can use this data set. This is sorry, this graph. This is going to be the perfect like the graph if you have the data based on the time series. Okay, and this is like using the lines to connect the data points. You can see here. This is the date on 2024 on 1st. So this is the data point we are using. What will be the value at this time? 100. Okay. And if you go this data point, and this is the value. So it is using the all data points on the different dates and showing you the frequency of the data. It is particularly useful for showing the trends and changes in the variable. Okay. The x-axis typically represents the time because we are talking about the time series, and y-axis you represents the variable being measured. Like at which time, on which date, maybe you are using the month only, maybe you are using the hourly data. It depends on your requirement, right? So it will show you the frequency on the based on the time series. Now if you are working in any data set which contains, you want to build the data insights from the time series data, this graph is going to be perfect for your data set. And when you should use time series, as we have talked, continuous data when you want to represent the continuous variable, right? And trend analysis for visualizing the trends such as increasing decreasing pattern over the time, right? And comparing the multiple variables. What does it mean? You may have the data from the different places. Let's say if I want to show the COVID cases from the different states, but it belongs to the same country, then what I can do? I can show here in the tooltip the different states. Here I can show the different months, right? And here I can show the frequency, right? I can draw the two lines. If I have a, let's say, 5 states, I can draw the 5 states, the lines here. And it will show me under the tooltip how many cases belong to this state, in which month, or at what time. Okay. So this is going to be very powerful, like the graph, if you have this kind of the data set. Okay. So what is the biggest advantage? It is a clear trend visualization because you can see the different trends. The frequency of the data is increasing between your 2nd to 3rd of January, right? Because your this a line is going at hike, but then it is going down. This is showing the downtrend between these dates. Okay, between these dates. And it is again going up from this date to this date. So you can easily read or interpret the graph like this way if you are working with the line chart. Okay, so it is going to show you the different trends up and down or straight, consistent. So this is very good graph and suits to you if you are working with time series data. Okay. Now the disadvantage is don't use it if you have a too many lines. Let's say I was talking about top 5 states. If let suppose if I have a 50 states, if not state, if I have 100 cities, right? If my stakeholder is asking me, just show the like each city's COVID cases over the time belong to each state, right? In one state, you may have a 20 cities, you may have a 10 cities, you have a 5 cities. So there are a lot of lines in a one graph. This is not recommended at that time. So what is the solution to this type of the graph? Then you need to create a different line charts for each state because your goal is now to show the each city graph based on the state. Then you can create the many graphs using line chart, but don't draw all lines in the single graph. Okay. Now tell me if you have already used this graph or you are using it. Okay. If you are now planning to use it. Okay. Don't forget to write down your comments in the comment box. Okay. Now we will move ahead with the use cases. So you can use it stock price trends because we want to see when, according to the time up and down, which stock prices are going to increase. You have seen on the TVs, mobiles, how the line this is show the trends, right, over the time. Temperature over a time, website traffic, sales performance, heart rating monitoring. You have seen in the hospitals, there are computers, displays, it shows the heart rate like this, right? So this is very useful graph. Okay, I hope you have an idea now where you should the bar graph, line chart and histogram. Okay, now we will move ahead with the scatter plot. This is, you can see here on the x-axis, I have these values, and on the y-axis, this is the y value. So this graph is very, very useful when you want to show the relationship between two variables. Okay, and the both variables should be numerical. Okay, because it is going to show you the relationship. If the value of the x variable is increasing, does the value of the y is also increasing? It will show you the three type of relation. For number one, positive relationship. Number two, your negative relationship. Number three, no relation. Look at this graph now. If the x value is 1, the y value is 10. If the x value is increasing up to 2, the y value is also increasing, right? If we look at the up to 5, if the x value is 5, it is also increasing. So this is showing the positive relation between two variables x and y. Okay, and if you want to show the relationship between the two variables, then you can go with the scatter plot. Okay, this is very popular graph to show the relationship correlation. Sometimes we use the correlation word as well. So this is the like a good term also used instead of a relationship. You can also use a correlation, how it is correlated with the x and y. Okay, and this is called positive correlation. If I say in any case, I will show you the negative correlation. This is called positive one right now. Let's suppose if the value of the x is increasing, if x value is 3.5, then your data point is here. Okay. And if the 4, then data point, if the 1, data point is here. Okay. So this means your x value is increasing, but this is decreasing. So this kind of relationship is known as negative. So x is increasing, y is decreasing. This is called negative relation. If your x value is increasing but y is not affecting, it is consistently going here, like all data points are here, then this is called no relationship. This is just the like consistency. If x is increasing, it is not affecting your y at all. Okay. This is very, very like the good graph, and when you should use it, when you want to visualize the relationship, as we have already discussed, when you need to identify the trends, like not you can say trends or relationship, like positive, negative, no relation, and you want to detect the outliers that did not fit the general pattern. What is the outlier? The point which is very far away from your normal data points. These are going in one direction. If I draw one point here, so this is called outlier. This is very far away from your mean as well. This is very far away from your normal data points. Okay. So scatter plot will easily show you the outliers as well. We have seen in the distribution graph, the your histogram. It was also show the your outlier as well at the tail, at the bottom. So in the scatter plot, it will show you with the data points. Okay. You are this is good when you are working with the large data sets because you can visualize your raw data points very clear. Okay, this is like the same advantages, and it also supports the trend line addition. So you can draw the trend line here. I will show you in the when we will implement it using Python. Okay, so it is only limited to two variables. You cannot use it for more than two variables because it belongs to two-dimensional data. Okay, it's a no precise qualification if like numerical without further analysis, right? So what does it mean? It is only showing you the relationship, but we will not be able to take out here the exact numerical value. If I wanted to see here what will be the value here, so it's a just over assumption, right? And it is a sensitive to scale differences. Again, as I have mentioned in the previous graph as well, if there is a lot of variation in your data values, then it is going to mislead you. So these kind of the points you need to keep in your mind. Scale your data first, then do the visualization. Otherwise, it will show you the different insights. Okay. So now we will move ahead with the use cases of scatter plot. This is you can use it for the stock market analysis, healthcare and medical research, marketing, sales, and real estate and social media. So these are the popular most common use cases of your scatter plot. Okay, if you are working any of the data set in this and you want to show the relationship between two variables, like for example in the marketing and sales, if you want to show how many money spent, how many advertisement making how many sales, then you can show the relationship between them. Okay, so this is all about your scatter plot. Now we will move ahead with the pie chart. Basically in normal, in real time, you use it rare. I never used it, frankly speaking. But this is also the good graph. You require it sometime. It show the percentage of your each category and show you the each slice with the different colors. You can see we have a here two, two, four slice, right? So it is showing how what is the distribution, how much percentage of apple values in your data set, 40%, and others means it may be mix of other fruits, and this is the Xiaomi and Samsung. Okay. Oh, it's not an Apple. This is your Apple brand. Sorry about it. Okay. So this is showing you the phone, different brands of the phone. Okay, and then the percentage available in your data set. You can use this graph if you want to represent your data set in a circle form and you want to show the distribution of the data in the percentage form on the slices, okay, and proportion to different your categories. At that time, this is useful, okay. But the here, it is easy to understand, it is visually appealing. You can also separate the slides as well. If you want to highlight, I will show you in the Python when we will write the code for this one. And but the biggest disadvantage, let's say there are only 1, 2, 3, 4 categories. If you have a 50 categories, what you will do? It is not going to show you the very good data inside, right? It may mislead you because there will be the very small slices which is not clear to your stakeholder. Okay, at that time avoid to use this kind of graph. Okay, and now we will look at its use cases as well. This is you can use for market share analysis, showing how different companies hold shares in the market, right? And budget allocation, if you want to display a company distributes in annual budget, like if they have decided the annual budget, this much money will be spent on the construction, this much money will be spent on the replacing the new monitors and so on, different categories. Okay, survey results, website traffic sources, election results. So these are the top most common use cases for the pie chart. But mind it, you need to keep in your mind the disadvantages as well. So don't try to use this graph if you have a many different categories. Okay, it will make a very small slice which will not clear to your stakeholder about the your data insights. Okay, and then box plot. This is basically, I would suggest we use it very rare for the stakeholder. This is for your backend work only. I never prefer this one for the stakeholder because your stakeholder can be non-technical. They won't be able to understand this graph very much. Okay, because it's little hard to understand. You can use this when you want to check the outlier in your data set, when you want to see the distribution of the data set, and it will show you the data distribution based on the quantile range. Okay, so your stakeholder is not going to understand it too much. If you are able to, if you are a good storyteller, then you can draw, but I avoid, mostly I avoid this for the stakeholders. Okay, So here, this is very useful for you at the back end when you want to show the categorical result for visualization that is represent the distribution of the data set using 5 key summary. Okay. So here you can see these are the different categories and it is showing the value on the y-axis. This is called the box plot. These the square boxes. It divided into these range. Minimum range Q0, the smallest value excluding outliers. It will not show the outliers in this. First quartile will show 25% of the data fall below this value. We can assume the 25%, the quantile 1, this is quantile 0, this is 25%, right? And this is your median, mean. Okay, and above this is called your third quintile, right? And this is the maximum quintile. If you have some data points here, you can see here that these dots, this is called outliers. Okay, and these are your quintiles. Quintile 0, 25%, this is median, then or you can say 50%, and this is 75%. So this means some data lies here as well. And you can see this is all here your median, so more data lies below this one. Okay, the largest value excluding the outliers. Okay, the Q4 also excluding the outliers because it is covering your most of the data distribution. You can see here this is the small box plot, right? It is not showing your Q4 range much, so it is showing you here the outliers. Okay, but here you can see it is covering the your outliers as well if you see this value. So in category A, there are outliers. Okay. And you use it basically, most popular this graph is for to check your outliers. Okay. And then you need to analyze the distribution of the data. You can see the distribution of the data according to the quantile range. And if you want to compare the multiple categories side by side, right? Because it is showing you A, category B, category C, the distribution of all your categories. We can see the category C has the very good data distribution. It has the large data points than the other two categories. This means this category C in your data set has more data than the other two categories. Okay. This is again the advantage is displays the data distribution. You can check the outliers. It is showing you compact and informative because it is making one big box. And then you great for comparing the multiple groups. Okay. And then it does not show the exact values. You can see here I'm not able to see the exact values, right? I'm only able to see the outliers. It's a median value, and this is going to be, it's a like a minimum quintile value, median value, quintile 4, 75%, and that's it, right? Because this is quintile 0, this is maximum value, and this is the mid value, and this is the 75% value. But I'm not able to see the exact position of my data points, right? And can be misleading with the small data set because it is less effective in that case, because your box is going to be very small in that case. Okay. Okay, so this can be like the sometimes confusing as well if the range of the whiskers varies depend on the data set. Okay, can be confusing if you have a many like the categories and you are drawing this graph. Some your categories may have a very small distribution, then it may confuse you and show you not the correct data insights. Okay, but this is very still very useful. Okay, because pros and cons of every graph is there. Okay, it depends how correctly you are choosing the graph. Okay, now we will move ahead. We will look at its use cases. It is used for stock market analysis, medical research, website performance, sales revenue, education and exam scores. I'm talking about the top most like the common use cases. There are more cases as well available. Okay. Heat map. This is one of my favorite graph, because it give you the very clear picture about the correlation of the different variables with each other. Okay. And this is going to be your best friend during analysis, believe me, because it is going to show you the relationship of each numerical variable with the target one or if you want to see the relationship between the numerical variables. Okay, so you can assume this is the your feature 1, feature 2, feature 3, feature 4. Okay, sorry, feature 0 to 4, and same this is a feature here as well. It How you will interpret this graph, it's a little bit hard to interpret like a box plot. The lighter the shade, here you can see lighter the shade, your less relationship, less correlated with the variable. Okay, so let's say if we talk about here on the right side, this bar, color bar, it's starting with the 0.1. This is means that you can convert it into percent, 10% relationship between the two variables, or you can say the relationship between dependent and independent variable 10% only. If your any box is with this color, we can see here it's a 0.3, only the 30% relationship, the feature 2 with your feature 4. And here if you read about the feature 2, here if we go up with the feature 0, it has a relationship with 23% only. This is 70%. You can see if you are increasing, the percentage of the relationship is increasing as well. Positive relationship, because if the value is showing there is a no negative sign, this means your this feature is strongly correlated with the other feature. If I give you the example of 4 variable, if you go up, your 0 variable is strongly correlated with your this variable 4 with 29% positively. Here it is strongly correlated with 91% with other features as well. Okay, so you need to look at it diagonally as well. This is the diagonally we see, and you can look at it like this way as well. Okay, you can check the feature 4 relationship with 4, because every feature is correlated with itself as well, right? And then you can check how the 4th your feature is correlated with the 3 as well, right? This is the 3, and then 2, then 1 and 0. Okay, this is the way how you interpret this graph. And now just tell me if you are already using this graph, and you how do you interpret it. And you can see it depend how you can interpret basically on the coloration, from lighter color to deep color, and the numbers it is showing. If it is somewhere showing the negative, let's say minus 0.55, so this means your third feature is negatively correlated with your this feature, the 4. Okay, and the other features as well with the 2, with the 1 as well. Okay, now what is the like the pros? This is great for large data set. This is my favorite graph, and easy to identify the trends as well, because I can check the correlation between the two graph variables, right, with the many variables, right? uh, and then useful for the correlation analysis, as I told you, positive correlation, negative correlation, and no relationship. Compact representation, no big graph, right? This is the its disadvantage is it is not ideal for small data sets. You can use then your line chart, right? If you have a small data set, you want to do the comparison, check the correlation, then you can go with the line chart. Okay, and it requires for proper scaling. This is important for all graphs, right? If there are a number of units, they are varying very differently, then it's hard for you to draw the graph. Okay, so it's very important to scale the data. Okay, now we will move ahead here with the next graph. So we can make it up, and then okay, the use cases are left. So these are the use cases. You can use it for correlation metrics in machine learning. Very important. Okay. Website click tracking, stock market analysis, customer behavior, and weather and climate data as well. Okay. Now this is a violent plot. This is you can use, I use it many times to again check the distribution. It's just like the box plot. Okay, but it is going to show me the two things. Number one, distribution. Number two, It's like the density. Okay, probability of the density, distribution, variability of the data. So you can see here, if you look at this portion, let me open my pen. If you look at this portion only, so this is more wider. This means there is the data distribution is large. If it is going to here thin, this is going to be less distribution of the data. Again, these are the data points. This is the mean of your like your data. Okay, and it is showing you the all data points here as well, and it is also showing you the tail has here as well. So there may be some outliers exist in this as well. Okay, it's very you if you have the different categories and you want to show the distribution plus the density of the data. Density means where the distribution of data is less, where the distribution of the data is more, or average, because it is showing you like the different shapes like this. Okay, so it is very good if you want to show the full data distribution, not like a box plot, because box plot is only showing you the not shape. It will only going to draw the square box. Effective for multi-peak data, right? And it is very good for multi-model distribution. Create for comparison, useful for comparison because you can do the comparison between the different categories. Identify the outliers and trends. You can see if it is going more thin here, it is a skewness of the data, outlier exists here. Okay, it's harder to interpret than the box plot, it's obvious. Don't try to like use most oftenly for the stakeholder. It will be very hard for you to as well to explain it. You need a lot of labeling on that, like this you need to tell what is this, what is this, and your stakeholder, if non-technical, basically it's very hard for them to understand. This is going to be best work for you if you're working at a back end and you want to look for the data distribution. At that time this is very useful. Okay, and basically again it is used for your different categories. Okay, not for continuous data. And now we will, and here the most important part, you can use it for the large data sets. Okay, and then this is the main like the use cases, sales distribution by job role, right? If you have a like a job role, you want to check according to the senior salesperson, mid junior salesperson, how many sales they have done at that time. You can use this. You can make a different categories here. Exam score analysis, again stock market, medical research, customer rating comparison. These are the top most common cases where you can use the violent plot. Okay, and now we will move at pair plot. This is also one of my favorite because it give me the clear picture of each and every your multiple numerical variable in the data set. You can see how beautiful this is, and diagonally it is showing the density distribution of each variable. I can see this is green one is normal distribution. This is little bit like a hair skewness, and there are more outliers. I can clearly look at this, right? So these are the different like your features, setosa, versicolor, your hair virginica, right? So it is showing the sepal length, width, your petal length, and sepal width, sepal length. Okay, so there will show at the bottom the same features. Diagonally it will show you the distribution of the data. Here it will show you the correlation of the data between each. Okay, here I the graph is cut off, so it is showing you the correlation of different, like how the petal length is increasing if the petal length or sepal width is increasing, in which direction. You can clearly see the relationship between the each feature. It is showing going everything in the same direction. This is positive correlation. If you look at this is maybe negative relation little bit, right? And it is also positive. Here you can see it is not affecting at all if, let's say, your sepal width is increasing, your virginica and versicolor, the blue one, right? Setosa has a no effect at all. Okay, only the rest of the two species is increasing. So this shows no relation. It has a no effect. So this will give you the very clear picture. You don't need to draw any separate graphs. This is just one line of command I will show you in the Python, and everything is set. But it is not like it is a like need a high computational power. If you have a many numerical feature, let's say you have a 20, it's very hard to draw this graph, right? So this is difficult to draw at that time, but it is a very good graph, your heat map and pair plot. If you are working as a data analyst, you are definitely going to use this at the back end. Okay. So this was all about your different graphs, okay, and their use cases. Let me show you the use cases. You can use it for exploratory data analysis, stock market analysis, medical data analysis, marketing and customer segmentation, house price prediction. Very useful. Okay. Now we will move ahead with the practical implementation. Okay. Here we go. I'm using the Google Colab. Okay. So now look at this. So which libraries we use in Python to draw the graphs? There are mainly two libraries. This is Matplot and Seaborn. I am going to use those two libraries to plot your all graphs. Okay. So first of all, you will learn how to draw the bar graphs using Python. Here we go. You need to import the Matplot library, matplot.pyplot as the plot. We will create the instance. Here I have taken the dummy data. Okay, I have created the different categories: product A, product B, product C, product D, and then the values. And then you will use the instance of the matplot.bar. This is the method you are going to plot. You will need to pass the categories, values, and color. Three parameters. Okay, so I'm using the basic functions today, but you can make a changes in this. I will share you the resources as well from where you can look at and make changes in your graph. Okay. So this is your plot X label. X label you are going to use to label your this X axis. Okay. Y label you are going to use to label your Y axis. Okay. Title is for your this one. Title of the graph. Okay. So these are the very basic thing in the matplotlib. And then finally, if you want to print it, you will use plot.show. So it will show you this graph. Okay. So how would you interpret? So here I would like to add one tip. Every student can print the graph by looking at the code. This is very easy. The challenge is number one, which graph suits best to your what kind of data, which we have already discussed a lot in detail. I hope you now understand and you will implement it definitely. Okay. Second most challenging job is interpret the result. You draw the graph, you think you are able to interpret, but when you give the presentation during the interview as well, it's hard for you to interpret the graph. So from the beginning, always try to interpret the results in a correct way. Okay. So you can see here, this is a product A, product B, product C, product D. Okay. And product A, what are the units it is showing? Up to 150. So if your stakeholder is asking you, tell me the product B sales, which product has done the highest sales? So you can looking at the graph, you can easily explain product B has done the highest sale above 175. Okay. And lowest sale is done by your product D. So you need to interpret the result as well. If you are facing a problem in during the interpretation, you can contact us. Okay. And don't forget to give me the write down in the comment which graph you are using. Okay. And why. And the next one is I have plotted the same graph using the Seaborn. The difference between Matplot and Seaborn is only Matplot is the parent library for the data visualization. Seaborn is your child library of it, extended library. In Matplot, you need to write a long piece of code. In Seaborn, you can write just one piece of code. This is the only difference, and it is a fast execution. But if you want the full control on your graph, then go with the Matplotlib. Okay. Here I'm using the pandas to generate the data set. And then I have just say SNS bar plot. But in Matplot, you were using the plot.bar. Here you will use a bar plot. And here the way to pass the values is different. you will say what you want to show on the x-axis, then you will say x is equals to products, y is equals to sales, what you want to show on the y, and then you need to pass the data frame as well with the data variable. Okay, and this is a palette. You can change it. I will show you how you can make it. There are inbuilt different palettes exist for the CPON. And then you are going to use the same like the labels X label, Y label, and the title, and here you go. Okay, so this is the way how you can print using the CPON. Okay, I have written the all code in advance so we can save over time. Okay, and then here you have the histogram, right? So the what does the histogram do? So now we will talk about histogram. First of all, again we will print it using matplotlib. So you can say here we are using the NumPy library to create your dummy data. Okay, I have used the data is equals to np.random.normal. So I am creating, I have given the size, scale, the difference of the bins, and then the location. Okay, log the values. Then it will give me the here data bins. So in histogram, we need to print the bins. I want to print the 20 bins. If you want, you can make 5, 10. This is your choice. And then you can pass the parameter color, edge color, and this is the black. Again, we will use the same. If you want to label X label, this one, Y label, this is for your title. Here you go. And now how you are going to interpret it? You are going to interpret it based on the scores. If a stakeholder is asking what is the highest score and the frequency of the highest score on this category, right? So here at the 70, if the scores are 70, how many like the scores it is able to frequency like the able to make a scores, this is 120. Okay, and this is showing little bit tail as well. Okay, although this is a normal distribution, this is, we cannot say there is a skewness, it's very small, we can ignore it. Okay, and here this one you can say outlier, but it is acceptable. Okay, acceptable means it is not a like I'm saying this is not very far away, right? It's not a very big like from the your this one, this is still normal distribution, little bit skewness is there. Okay, so it is also showing the distribution of the data of your different categories. Okay, and now you can plot the same graph using your CBON. Okay, so here you need to use histoplot, but what we have used in this hist only. So this is the difference. But you can use any library, this is your choice. It is not like I am recommending anything to you. I have told you the pros and cons both, so you can use anyone according to your convenience, but do the mastery in one library what you like. Okay, here in the SNS it is also showing us the distribution line as well. You can see here this is the light sky. Okay, so it will help you to show the skewness as well. Is it normal distribution? It is left skewed, right skewed. This is not like everything it is going to show you. Okay, skewness means your data is going away from the mean in a like a no data, very less data, then it will make a tail. Okay, and then you have a line chart. Again we are plotting it creating the dummy data using the days and sales, how many sales are done in this day. We are using the numpy and then we are plotting. Look at this, on the first day how many sales were done? 100. And then on the day 2 how many sales done? 120. So it is going, the trend is showing up right now. But when it reach on the third day, it is little bit start going down and it goes very down on the day 4. So how many sales are done on the day 4? 110 only. So this is less than from your day 3, right? And also from day 2, but it is larger than from your day 1. So this is the way how you can show the data insight to the stakeholder. Okay, and then it is start increasing again and it is going up and up and up. Okay, so now here you will tell the reason, you can give the recommendation by looking at this graph to your stakeholder, why on the day 4 your sales were so down, and what you can do to increase your like the revenue or sales on day 4. So this is your job now as a data analyst. Okay. And now this is a legend. You can add it here using your this one line style, and this is by default added using this one plot.legend, and there it has many parameters. I will share you the documentation. You can add change the colors, and you want to show it left right, this you can do. Okay. And then we are plotting the same graphs using Seaborn. In Seaborn you are going to use line plot. Here you were using the plot only. Okay. And now look at this figure. Figure means this is figure. Figure size means this is your 8 rows, 6 columns. Okay. How big a graph you want to print. This is just the basic thing. Okay. We use it. And line width, you can set up how thin, thick line you want to show. And your color as well. Okay. Marker means O. Like what you want to show as a marker on your data points, like this one. Dots. Okay. Here you can again it is showing the same result as we have discussed. Okay. Line chart is showing you over the time the different trends of the values, sales done, and how it is going up and down. Okay. Now we will talk about the scatter plot, again very important when you want to show the relationship between the two graphs. Okay. In matplot we have generated the random data set here. We are converting it into data frame, setting the figure size, and in matplot you need to use a scatter. How you are passing the value? If you are passing the value using the data frame, then you can say data frame, name of your column you want to display, and second column, and color and alpha. Okay. So we will print this one. Here we go. Okay. So here it is showing you advertising spend. Okay. And this means how much money you have spent and how many sales are done after spending this much dollars. Okay. So you can see if $1,000 were spent, what was how many sales? We can look at this point only, then it's around 1,000 sales. Okay. But if you spend the $1,200, your sales is increasing. It goes up to 2,000 sales. And then you can see here the data point as well at the $1,500. If the stakeholder is spending 5,000, you can say the sales increasing up to 3,000 above, right? So this is showing the relationship between the money spent on the advertisement and how many sales are done. If you are spending more money on the advertisement, more sales are happening. Okay, so this is showing positive correlation. If you are increasing the money and you are increasing the advertisement, then sale is also increasing. This is the way how you will like interpret this one. And this is in your matplot you can use the scatter plot this one, and you can increase the size here, you can increase and decrease this size, there is a no problem. Okay, if you want you can make it 10, you can make it 6 or 8, this is your choice. It will increase little bit size, you can see. You can change the color of your title, this one, and you can also add the legend as well. I will share the documentation with you about it. Okay. Now we will talk about how you can draw the same graphs using Seaborn. You can see it's a huge difference. In the Seaborn, you can also show the trend line as well. So it is easy for you to discuss the relationship between the two variables, because this line is going in this direction. If your spent money is increasing, your sales is also increasing and it is going in this direction. So this is showing positive correlation between the advertising spend money and sales revenue. You can see many data points are aligned on this, right? So this is very close to this one, but you can see here there are the outliers as well, because this is very far away from your trend line, as we have discussed when we were discussing using this rise theoretically. So I told you The scatter plot is also help you to detect the outliers as well. So you can see this is the outlier because this is very far away from your actual these points. This is the line which is best suited to your all data points, where your all data points are close to this line. We draw the line where all points are very close to each other. Okay, so these counted as an outlier. Okay. And now we will move ahead with the pie chart. Here the pie chart using the matplotlib. This is the pie chart. You can use the plot.py. Okay. And you can use the same like the budgets in this. Oh, sorry. The title, and you can plot it. We will run this one. Here we go. See. You can slice out if you want to highlight any slices specifically. Okay, so this is showing the company budget allocation on the different departments: marketing, HR, sales, operations, development, right? So they want to highlight the biggest budget allocated, that is on the development. So that's why this slice is cut from the other one. And but it is showing very good picture. So now how would you pass? This is a budget allocation. This is your list of the budget allocation labels you are labeling. This is the another list you have declared, and it will label on this automatically. And these are the colors: start angle 140 degree, and explode. This is how much like the percentage dividing on your this like the pie chart. Okay. Shadow is equal to true means this one, it is showing some shadows. Okay. Explode means you are exploding this one. Okay. Slice out. Okay. And then we have the next one is your box plot. Okay. So box plot using your here we are printing like this way. This is using Seaborn. This is using your matplotlib. This is category A, category B, category C. Again, it is showing you the quantile range. This is the outlier. This is the outlier. This is the outlier. This is above your 75%. Okay, because this is your maximum quantile range. This is minimum quantile range. This is the median quantile range. Okay. How would you print? You will use the box plot method in this. And how the parameter will pass? df dot values labels. How you are labeling it? df dot column. So it will automatically pick up your column names, the categories. Okay. Here you go. This one. Category A, category B, category C. And then patch artist is true. We want to show the box clearly because I want to add the color in the box. If I don't enable these things, then your box will not contain any color. It will only show you the outline. Oh, sorry, outline. Okay. And here you are printing it using Seaborn. This is very easy. In Seaborn, you can see very less piece of code, right? You only need to pass the data frame and palette. That's it. Everything is done. Okay. Now choice is your what you want to use. Okay. The next one is heat map. Heat map, you can use SNS heat map. I'm drawing it using my this one. So again, this is showing the correlation, and it depend upon the color bar. Lighter the color, lower the value, lower the correlation. 20% is low correlation, positive. Higher the value, dark the color, and it will show the strong correlation between two variables. Again, it's very easy. You will have the data. I'm generating the dummy data. You will have your own data set, and then you will pass sns.heatmapdf. Annotation is equal to true means it will show you these numbers. If you don't do this, it will not show any number. It will only show the colors. And then cmap cool warm line width, it's a format 0.2f means you are setting up its decimal value up to 2.22 numbers. If I don't set it, it will show you the many decimals. Well, after the decimal, it will show you more than two numbers. Okay. So this is important parameters you can pass in this and then draw the graph. Then here you have a violin, your plot. This is you can use. Again, we are creating the data frame with the categories and values, because it is going to show you the your distribution of the different categories, right? And then SNS violin plot, very easy. What you want to show on the x-axis, say category, it should be the name of your column, okay? It should be name of your column. And then y is equals to value, next column name. Then pass the data palette. This is a palette color scheme. Seaborn has a many color palette. You can change it according to your choice. Inner, they want to show the quantile. So look at this. This is the quantile. Q0, median and maximum one. These dotted lines. So this is the tail skewness in the data. Outline exists in this. Okay. And then we have a pair plot, my favorite one. Very easy to plot, I told you. Only SNS dot pair plot, pass the whole data set. Hue species means we are showing the data with the hue effect. This one. Okay. And then diagram kind, KDE. This is your color density exploration. Okay. Now look at this graph. So diagonally, it is showing you the distribution of the data. Either it's a normal, it's contains outliers, skewness. This is skew, this is a skewness. You can see here. The tail is going down. This is the normal distribution. This is the outliers. Okay. So here you can see if the relationship you check between these two variables. If the sepal length is increasing, right? We can go here. So gray color is for your versicolor. So we can check here. If the sepal length is increasing, your versicolor petal width is also increasing, right? And here you have a setosa. If setosa is at this point, even your petal length is increasing. It is so this means your setosa is not affected by your petal width. Okay, so this is no relation. This is consistent. This is little bit increasing here, but still it is stop here. This is increasing. So most the effective it is showing the strong correlation between the petal length, petal width, and petal length between the versicolor and virginica. Setosa is very less effective due to its petal width, petal length. Okay, so these are the small graphs, and this was all about your graphical representation. I hope you understand which graph is useful for what type of your data set, and I hope you will be able to print the now correct graph, choose the right graph, and you become a very expert data analyst. And in last I will show you the resources. So this is the seedborn. Okay, so you can uh, I will share these links in the description box as well. You can choose the different parameters, and you can change in the code and try it. Okay, same you have the library of matplotlib as well. Okay, so it contains many graphs. Okay, you can go with those graphs. These are the tutorials, and you can choose the graph, and it will also help you to print what kind of graph is good for what type. Okay, so it is a kind of revision. You can use a small copy and paste the tutorials and print it. You have a 3D graphs as well in this. Okay, I will share all links in the description box. And this was all about today's video. I know it's it was a long video, but believe me, if you were watching till the end, it is going to be very beneficial for you, because my every student always stuck at a beginner level which graph they should draw for what kind of the data set. Okay, it's a big decision, because if you want to be a data analyst, it's a very important thing for you. Okay, so now I will take a leave from all of you, and keep patience, keep learning, happy AI learning, and don't forget to subscribe my channel, and don't forget to comment as well which graph you have used for what kind of the data set. Okay, thank you so much for watching this video. See you in the next video.